right, this is question 15 that Zach's asked me to have a go at. Right, so we've got 4 buoys on the large calm lake, so that's assuming that we're not worried about them bobbing up and down and stuff. And they're located at A, B, C and D with those position vectors. So the position vector OA just means where A is in relation to O, so how you'd get from O to A. So that's 410 in the positive x direction and 710 up, and so on. So they're really just coordinates. Position vectors are just coordinates, really. Right, so I've plotted them using GeoGebra, so I've got an idea where they are, but obviously you don't have to do that. I'm just doing that to show you what I would do. Right, okay, and then, right, we want to prove that it's a quadrilateral. Oh, prove that the quadrilateral ABCD, so that's if we join them all together, is a trapezium but not a parallelogram. So a trapezium has one pair of parallel sides, okay, one pair of parallel sides, whereas a parallelogram has 2 pairs of parallel sides, okay, 2 pairs of parallel sides. And on a parallelogram, those parallel sides are also the same length. They'd have to be, otherwise it's not parallel. So like that, well, that would be a parallelogram. Whereas a trapezium's just got one set, that top and bottom there would be parallel. The other 2 sides can be anything. And obviously they can have any orientation you like. So, to show that they're parallel, how are we going to do that then? So if 2 vectors are parallel, then we can... Now, is it enough to look at the lengths of the sides? No, because that's not what we're trying to show, is it? We're trying to show that they are parallel, not that the sides are the equal length. So we need to look at the vectors. So if side here, if the side, this side here, BA, if that is parallel to that side there, if that's parallel to CD, then the vector AB will be some multiple or other of CD. Okay? So the vector, we can either say B to A or C to D, D to C. It doesn't matter because we're looking at whether one is a multiple of the other. Right, so first of all, let's work out what BA is. Right, so BA, the vector BA is going from B to A. Okay, so we're going from minus 210 up to 410. So that is going to be minus 200, the modulus of minus 210 plus 410. So that's going to be 620. Okay? Because we're going 620 from there along there. And then on the top, we're going from 530 up to 710. So the difference between those two, 710 minus 530, is 180. Okay. Now let's have a look at the vector CD. So C to D, you're going from minus 340 up to 590. So 590 minus 340, or add 340 is 930. And then on the bottom we're going from minus 310 up to minus 40, which is a positive 270. Okay, so can we find, so if they are a multiple, then if we do 620 times something, let's call it K, we will get 930. And if they're parallel, then 180, this 180 here, times that same constant K will give us 270. So we're going to use this one. I'll use this one to work out what K is. That tells us that K is 270 divided by 180, which is 3 over 2. So the question is 620 times 3 over 2 equal to 930? Why have I written 6 over 3 instead of 3 over 2? I'm mad. Okay, so if they're parallel, then there's some constant that we can multiply them both by to get that other vector. And that tells us that they're parallel. Oh, and that is true. Right. Right, therefore, this constant K exists. Therefore, the side BA is parallel to the side CD. Okay, now we need to do the same thing for BC and AD. Okay, so if we look, first of all, look for vector BC, that tells us the vector BC is, we're going from minus 210 down to minus 340. So minus 210 minus minus 340 equals 130. Is this BC? No, that's CB, isn't it? So C to B. Right, I'm going C to B. So I'm going 130 that way. Right, yep, 130 that way. And then you'll work out the bottom one. So minus 310 minus 530. So that's going to be minus 840. Sorry, this top one should be minus 340 minus minus 210. So that's minus. Okay, and then you work out vector AD. Okay, so the vector AD, you're going from D, which is, so you've got 590, 410. So vector AD, you're going 150. What's wrong with me today? I can't do any sort of sums at all. It's because I've been weeding. Right, 180. Talking rubbish there. Okay, so that from A to D, we're going 180 that way, and then we're going from minus 40 minus 710. So we are going minus 40 plus 710, 670 down. That's not minus, it's just minus. Oh, honestly, sorry, I'm confusing myself. It's just minus. Right, minus 40 minus 710 is minus 750. And the question is, can we find, that'll be minus, won't it? Going from 590, B to C. Is it parallel to A to D? So B to C, you're going, oh, well, it's clearly not, is it? Because one of these is positive, one of these is negative. That's plus 130, isn't it? Right. So clearly there's going to be no constant that we can multiply to show that though, you could do the 130 times, let's call it m, equals minus 180, and minus 840 m equals minus 750, and clearly we can't find an m that is going to make that true. So to prove that it's not a parallelogram, you have to show that there is one pair of parallel sides, but that the other two pair of sides aren't parallel. Right. Okay, a speedboat travels directly from B to C at a constant speed in 50 seconds. So it's constant speed, so we can use speed equals distance over time. Find the speed of the boat between B and C. So how far, or what is the distance between B and C, first of all? Okay, so if you don't like vectors very much, you could use just Pythagoras here. So we said that distance there, BC, was 130. That length there is 130. And this one here is 840. 530 down to 310, yeah, 840. So you could use Pythagoras there to say that the length of BC is equal to the square root of 130 squared add 840 squared. Whee! Okay, so you can work out your distance there. You'll work that out. You've got your time. So if you're going to use, and it tells you here all these values are in meters. So your speed you're going to use your STD triangle. Speed equals your distance over time. You're going to work out your distance there, divide it by 50. That'll give you your speed in metres per second. Oof. Hope that helps.